Welcome to INTERFACEWARE's first webinar of 2021. My name is Prashant Sri. I'm the head of marketing here at INTERFACEWARE, and it is my pleasure to welcome everyone here today, whether it's morning, evening, or afternoon. Today's session, Interface Design Best Practices, will be hosted by our very own Marcus Walters, our solutions consultant. Before we begin, I wanted to take and share just some housekeeping items. There will be opportunities to ask questions at the halfway point and at the end of this session. You'll be able to ask questions by typing it out through the question box or through voice if you so desire by raising your hand. We'll also be sending up a follow-up email Monday morning for anyone wanting to rewatch this session or to share it with a colleague. Finally, we have more details about this at the end of the session, but we'll have a post-event survey and would really appreciate if everyone took a moment just to fill it out and provide us some much needed feedback. It now is my pleasure to welcome our speaker today. Marcus Walters is a solutions consultant here at INTERFACEWARE who works primarily with our enterprise clients to help solve complex integration problems and also to develop robust, reliable, and consistent high availability architectures. After graduating from Ryerson University with a bachelor's degree in biomedical engineering, Marcus went straight into the healthcare field and has been with INTERFACEWARE for almost 3 years. Outside of work, Marcus likes to spend his time making electronic music and is actively striving to become proficient in Japanese as a second language. It's my pleasure to give Marcus the floor now.
Thanks, Prashant. And thank you again, everyone, for taking the time to join this webinar. And for those of you who are new, it's great to have you here. And for existing attendees, thanks for your continued interest. We appreciate the time that you've set aside to make it today. And to start off, I'd like to go through a quick overview of the topics that we'll be discussing today. Firstly, we'll start with an introduction on what an interface is within the context of Iguana. We'll then discuss design patterns that can be incorporated to achieve an interface. And along with this, we'll discuss ways that you can store and recall configurations that will be used in those interfaces and how you can secure them at rest using Iguana. After that, we'll go through a quick walkthrough of a sample interface that will go over the topics that we had discussed. And then finally, we'll open it up for a Q&A at the end of the webinar. So in terms of what to expect out of this webinar, I'm going to try my best to go over what the topic is, why it's important, and then try to provide some practical examples or usages of the concept that you could apply right now with Iguana. My goal for the webinar is for everyone to leave knowing a little bit more about Iguana than they had already known today. And anything more than that is great and hopefully can be applicable to any of your upcoming integration endeavors. Okay, so introduction. First off, what is an interface? Here's a little black box diagram of interface with messages going in and out on the right. An interface is simply a component or a system that moves data between incompatible systems. This data is commonly transferred as HL7 data, but it could also be other types of flat file formats such as text, CSVs, and et cetera, et cetera. What does an interface do? So in essence, an interface does one or more of the following things. It reads messages from one or more sources. It filters out messages that could not be forwarded or that should not be forwarded. It processes messages to change formatting or to add codes, check data, et cetera, et cetera. It maps messages from the incoming to the outgoing message formats. And then lastly, it transits messages to one or more target systems. So with that in mind, what kind of interface types are there? So interfaces can be broadly categorized into two types, which are simple interfaces and complex. A simple interface is one that transfers information from a single source system to a single target system. So you can see here on the left, there is one single source, which is a hospital, and it's sending data through Iguana to a single target, which is a laboratory. A complex system, on the other hand, is one that involves more than two systems. So more providers on your inbound that are sending messages again through Iguana to multiple targets on the outbound side. A common example is when you're sending data from a single source system to multiple targets. So like a one-to-many sort of scenario. With all that being said, where does Iguana fit into the equation? Iguana essentially simplifies the process to make interfaces. Channels, which is the de facto unit in Iguana, can be linked together to create interfaces, and you combine as many channels as needed to fit the complexity of the integration. And we can also work with all types of source and destination protocols, such as LLP, APIs, et cetera, HTTPS. And ultimately, interfaces allow you to automate workflows for you to streamline your data from point A to point B. So now that we've gotten a good overview on what an interface is, let's look at some of the design patterns in Iguana that are possible with them. So design patterns in Iguana are critical in developing interfaces. Design patterns orchestrate each of the 5 assets of an interface that we had talked about previously into workflows that make healthcare problems very simple to solve. Instead of reinventing the wheel every time a new interface is required, utilizing an existing design pattern will drastically reduce the amount of time needed to design and roll out an interface, as it's essentially an existing solution that's reapplied to a different scenario. Although there are a myriad of patterns achievable within Iguana, today I would like to highlight 4 that are used more often than others. So these are the canonical data model, message enrichment, one-to-many, and many-to-one. So these patterns each prioritize the various facets of an interface in order to move data. So let's go into a bit of these each in a bit more detail on the next coming slides. So the first design pattern of discussion is the canonical data model, or CDM for short. The CDM is a data superset that, when combined with a translator, allows for a centralized medium in which messages can be exchanged. To put it simply, it's the part of the system that normalizes your data to a particular standard as the data flows through it. So as you can see on the right here, there's a diagram of an interface, and on the left, messages are coming in with A, B, C, and there's dashed lines in between them. And our channel, which is part of the interface, normalizes it and converts them into a dash schema with bars in it. The CDM can be part of a simple or complex system, and in Iguana, it may appear as a data mapping inside a filter component, a database insertion via the translator component, or as an explicit conditional filter inside a filter component of a channel. The value of these methods and this design pattern in general is that they act as a centralized way to exchange inbound and outbound data without the need to develop additional translation logic. The second design pattern is message enrichment. So in this design, a message is essentially enriched, which means that new data that was not available in the message has been added. So if you look to the right, this diagram highlights how a translator appends data as it flows through it. The message initially starts off with A, B, C, and then we have a translator inside that adds a D component. And as the message goes outbound, it now has more data or modified data that was not there prior. Message enrichment can be both simple and complex. And in both scenarios, there may be more than one message enrichment occurring. So what that means is you might have multiple stages in which enrichments might occur, and some might not be necessary depending on the type of message. In complex scenarios, message enrichment may depend on the relationships between inbound and outbound clients. And usually, yeah, that's more for a complex scenario. And in Iguana, message enrichment can normally be achieved in a couple of ways, including via database lookups in a translator component or message mapping inside a filter component. The third design pattern for discussion today is the one-to-many design, or OTM. The OTM is a complex design pattern that routes data to multiple endpoints. This data may propagate omnidirectionally, as into every endpoint, or dynamically, depending on the message content. One-to-many integration designs can be achieved by typically utilizing the queue components of a channel in Iguana, as well as by local LLP connections. If a filter is used on the outbound channel endpoint, it can be programmed to let only valid messages through, which essentially achieves dynamic routing. So as you can see here in this diagram on the right, we have an Iguana source channel that has a translator component, and via its logic, it's able to then send messages out to each of the respective LLPs, and then the filter component that comes afterwards can then check and send only particular messages through based on criteria. Moreover, on real world usage, this workflow can be used not only with external clients, but actually with internal systems. So one client that I actually worked closely with was using a one-to-many workflow to route data from one Iguana inside their network to multiple other Iguanas in their system that each handled like various tasks such as database operations, API connections, and etc. The last design pattern of discussion is the many-to-one design, or MTO for short. The MTO design is a complex design that takes in data from multiple sources and routes the resulting data into one destination. The design can be asynchronous or synchronous, with the former meaning that any source data coming in is independent of other sources going out, and the latter meaning that outbound data relies on one or more of the other inbound system data being sent together or in a particular sequence. Some of the common ways this design can be achieved in the Iguana is by setting the destination queue of multiple channels as the source queue of one channel, as seen in this diagram here on the right. If the message needs to be synchronous, the use of an intermediate database, such as SQLite, can also be used to pool all the required data until it's ready to be sent outbound. A real-world use of this design pattern is usually with clients who need to ensure that the correct sequence of trigger events are sent to the downstream application. Okay, so now that we've gotten a good overview of some of the design types and how we could do them in Iguana, let's actually talk about ways that you can store and recall the configurations that would define these interfaces. Because there are a variety of configurations that actually exist within Iguana, such as translator configurations, configurations for user accounts, for port, et cetera, et cetera. Today, the scope is going to be focused primarily on configuration data that's utilized within the context of the translator. So first, why would you want to store and recall configurations in Iguana? This process essentially helps make interfaces more dry, as in don't repeat yourself, and template ready. In addition, utilizing repositories to store information minimizes code changes needed for different environments. So example, production, development, or test. And all in all, configurations help mitigate deployment efforts in the short term and maintenance effort in the long term. Okay, so there are a couple of great ways that you can store configurations in Iguana. And the three that I'm going to talk about and discuss today are our configuration scripts. And these can be internal, such as a Lua script, or external, such as a JSON or an API endpoint or something. And finally, Iguana environment variables. Typically, configuration stores are usually differentiated between development, test, and production environment. So that would mean you have a development database versus a production database that each require different credentials to connect. And depending on the infrastructure, the terms of dev, test, and prod, they might vary. It could be staging, it could be QA, but they all essentially solve a certain part of the workflow. So now I'm going to dive a bit deeper into the 3 types of configuration stores that are listed here. Okay, the first storage type is the Lua configuration script. So a Lua configuration script is a script that contains the input parameters needed for a translator script to function. So as you see here on the right, here's a diagram, or not a diagram, but a picture of an Iguana translator. And on the left, you can see in the little pane there, there's a config.lua script that's highlighted in blue. And on the right, you can see that there is a parameter called HL7VMD parser vmd.vmd. So that probably means that this variable is used throughout the code in multiple places, and you have a centralized place that you can use to then access and change the variable without having to change the rest of the code. Again, parameters are usually differentiated between development, test, and prod environments, and usually a Lua script with a name like config.lua can be used to store parameters. Moreover, the script can actually be made to be local or shared depending on the need, which means that if you know that the variables here are being used in more than one integration, you could potentially have it in the shared part of the translator project tree as opposed to the local part, which this configuration is currently in. Because the Lua script is a Lua script, once the translator it resides in is committed, all the data that's there, it persists in source control. So this is a consideration that you should think about when it comes to designing interfaces. And the reason I say this is because if you're to use a straight up config.lua to save credentials like passwords or something, once those are committed, they will persist in source control. And what that means is, say you create some code, you then hit the commit button to save your code, and then you save again, and so on and so forth. If you look at the history for that channel, you can scroll back and you will be able to find the passwords or the credentials in plain sight. The second storage type is the Iguana external configuration script. So an external configuration script is any type of flat file that contains the parameters needed for one or more translator scripts to operate. These files, again, they usually vary depending on the environment. And an example would be a config.json file. So this may be local to the Iguana, appearing on the same disk, or it could be on a shared drive or a network share somewhere. The main difference here between the previous internal script that I talked about and this one is that this is external to the Iguana environment, as in it's something that's accessed outside of Iguana's dependencies. And because of this, its information is actually not directly accessible from source control unless the file is actually added as a dependency to the project. And also, depending on security, the contents of the file may be in an unencrypted form. So moving on, the third storage type is essentially via Iguana environment variables. So environment variables are variables defined in the Iguana settings that are used to configure both channels of Iguana and the Iguana instance as a whole from the system level. So that would be things such as the Iguana application path or any chameleon directories and so on and so forth. These variables are actually exclusive to one Iguana instance, meaning that they can't essentially be remoted and connected. You can't use one Iguana to then remotely access its environment variables unless you explicitly define them somehow. And again, these variables are accessible to all channels. So what that means is if you have 10 different interfaces that rely on a particular parameter, you could put that variable inside of your Iguana environment variables, as seen here in the screenshot. And then via an API, os.getEnv, you would be able to access the variable across all of those interfaces. Again, the typical use case for these variables is to declare one first here inside of the environment variables. And then when inside the translator, you would then use the os.getEnv API to then recall it and then be able to use it for whatever purpose. Okay, so with all these configuration stores in mind, let's discuss some of the best practices that we can actually apply to them. So to get the most out of your configurations, it's advised to use a mix of the configuration stores that we've talked about here. Each method has the both pros and cons, but a clever mix of the solutions, depending on the interface requirements, it can really help mitigate the individual cons greatly. As interfaces become more complex and plentiful, so will your configurations. So it's important that you initialize them inside of the translator before the main function block. This ensures that the variables that you define are only declared once, and it can drastically improve performance. So this practice is actually advised more so for external configurations, as loading those files directly from disk is a more intensive task. It consumes more overhead. So instead of declaring them inside the main, which is run every single time a message is passed through, it's best to declare your variables before that so that it's only initialized once and will persist for essentially the lifetime that the channel is on until it turns off. Lastly, if you find that you're copying and pasting variables often throughout your interfaces, it's advised to consider abstracting the variable in code and moving its declaration into your configuration script. So what that means is if you find that you're using a variable twice, thrice, everywhere in almost all your scripts, it's best to abstract that and put it into another script that each of the respective scripts can then recall from, so that you don't have to worry about where you change that variable globally. And again, later on during the interface walkthrough section, we'll get to see all these best practices in action.
Thanks so much for that presentation so far, Marcus. We've reached the
Of course.
halfway point, and I just wanted to open up the floor for any questions that any of our attendees may have. There are two opportunities here to ask a question. At the bottom of the Zoom platform, you'll see a Q&A box, as well as if you want to make a voice question, you can raise your hand as well. We'll also have an extended Q&A session at the end of Marcus's presentation as well. But if anyone has any questions thus far, feel free to ask. So we do have one question.
Sure.
And the questioner is asking, I would love to see the storing credentials outside of the Iguana Lua file again. So I think that's more of a suggestion.
Okay. So the suggestion / question was seeing how you could store environment variables outside in like an external configuration script. Is that correct, Prashant?
I believe that's what the questioner is asking. I'll repeat it once again. And I think it's more of a suggestion. I would love to see the storing credentials outside of the Iguana Lua file again.
Okay. So what I can say, at least in the short term, is that there are particular APIs inside of our documentation that you can use to specify external files, such as the file.io. I don't have that on the slide here, but file.io and fs.stat and a bunch of other related APIs, when you write them inside of your code, those would be the best way to then refer to any external files outside of the Iguana system. So that means that if you know you have your My Documents folder, if you use the file API, you can then specify the directory and the particular file to then pull into Iguana. And then by parsing it, because it might be a string or a JSON, you can then use that. I think as a follow-up, what I'll do is let me make a note of that here. I'll add a bit more information into the slides at the end that you can then use for your leisure.
Great, Marcus. Thank you. There is another question as well. And the questioner is asking, do you have any examples of a good use of message enrichment? Any examples of when not to use message enrichment?
Okay. So do I have any good examples of when to use message enrichment versus when not to do message enrichment? So one of the examples that I see a lot is depending on the interface, you might need to embed a PDF or some sort of image that might come from a lab or something. By using the SFTP command or by using the SFTP component, you might be able to then pull in a message into Iguana, and then using some other related functions, such as the base.64 encode function, you can then convert a particular large file into a string that can then be appended to a message. So that's good in the cases that you have any orders or results from like a doctor, someone that, it's not necessarily in the right format of HL7 that you can use to then distribute throughout your providers or any other integrated or connected systems.
Fantastic.
The other thing, sorry, the other thing that I heard was there's two parts of that question, right? One was how you could do cases of enrichment and then cases of something else, correct?
I'll repeat the question once again.
Sure, sure.
Do you have any examples of a good use of message enrichment? Any examples of when not to use message enrichment?
Okay. So I don't have any off the top of my head for when not to use message enrichment. Normally, that would again depend on the criteria that you might have for an interface. And essentially, if there's no need for you to have any additional variables added, such as accessing a database to then do a code map or something, it's best to use as minimal code as possible as to not increase the overhead for a particular interface.
Great. It's great to see a few more questions coming in. So we'll take two more questions now. And like I said, we'll also have an extended period at the end for anyone to ask any questions at all about Iguana. The next question is, may I know the difference between VMD and config.lua?
Sure. So in a nutshell, a VMD is a visual message definition. That's what it stands for. And it's a type of file that Iguana uses to then parse out an HL7 message. If you've ever seen what an HL7 message looks like, it's like a bunch of text that has a bunch of bars and everything in between it. And normally with any sort of coding application, if you don't have a schema or a way to parse it out, it's not really easy to work with. So in our complementary application Chameleon, you're able to create VMDs that specify particular segments of an HL7 message, such as MSH, the PID. And then when you import that into Iguana, Iguana is essentially able to take that VMD, it pushes the text file through it, and now it's in a form that you can use freely inside of the translator to then get pieces of data, send things, map things, et cetera, et cetera. The config.lua, that was an essentially example of a central repository in a particular translator instance of a channel. That is an area that you can then put variables that you might use often inside a piece of code. So as an example, if you're doing multiple message parsings or creation of HL7 messages inside of a translator, you might want to use a configuration script to then reference that VMD, as opposed to hard coding in the VMD location 5 or 6 times, how many times that you might use that VMD within your code. If you put it in one spot, that means that via the abstraction logic, it'll automatically apply for all the scenarios that you use that variable inside.
Fantastic. We'll take one more question. There's a few other questions coming in, but we'll also have an opportunity at the end, once again, to ask to do our best to answer all these questions. So here's the final question for this segment, Marcus.
Sure.
Is there a preferred method to connect to a database? I've seen ODBC used and was wondering if this is still a preferable method.
Okay, so the short answer is yes, ODBC is still one of the useful ways that you can connect to a database. It honestly, again, we can work with Iguana at its core, can work with a lot of external systems, and it's more so about what you guys have and how compatible it is with Iguana. So at least from our documentation the last time I checked, ODBC is definitely a really good way to connect. It's a way that you can connect to multiple databases at once, and it's sort of universal, at least across all of the Windows servers. So at this point in time, if you're already using it for a particular database, that would be okay. However, I do know that as we go into the future, databases are already starting to transfer to the cloud, and that API calls are becoming more common. I would say that in those scenarios, that is also again a preferred method that you can use. And as long as you have the right latency or you have a fast enough network, or that all of your Iguana dependencies, for example, are on the cloud wherever that data lies, no matter what method you choose, it should still be fast and efficient from the Iguana's perspective.
Thanks, Marcus. We do have a few other questions, but we'll get to them at the end of the presentation.
Sure.
I guess you can continue onwards.
Okay. Yeah, great. Okay. So now that we've gotten a good look at the ways that we can store configuration variables inside of Iguana, let's see how we can store the more important ones, at least some of them, more securely and at rest. Okay, before I sort of go into securing credentials at rest, I actually want to take a step back and elaborate what I mean when I refer to data at rest. So data at any given point in time is usually in one of the following forms, and there's three of them. One is at rest, which means existing idly in a storage medium, so like a hard drive or a shared drive or something not being used. The second is in transit, meaning it's en route to a destination, so that's it actively passing over your network or to one of your other interconnected services. And then lastly, in action, where it's being used directly by a service or an application. So that would be, for an example, in this case, we were just talking about Iguana and external variables. Iguana actively pulling an external variable like a JSON or something, that would be it in use. Of the three types that I've mentioned, data at rest is subject to risk if the related storage medium is not protected or encrypted properly. So to put it simply, if data is acquired in this form with no protection, a hacker would easily be able to read and manipulate the data for any malicious purposes, such as using credentials to like gain access to databases that might have patient data or something like that. And with all that being said, I'd like to say that we do take credential safety in Iguana very seriously when designing interfaces. And the reason is because credentials are very vital into administering data. These include things such as database credentials, which we had talked about, any API credentials and client ID or secrets, just to name a few. An improper securement of these might propose critical security risks, such as data leaks, which may compromise PHI integrity, and then you go down the HIPAA hole of legal issues. And since companies may require credentials to adhere to encryption standards, ensuring that credentials are deployed in a way that mitigates their persistence is key. So with that context in mind, INTERFACEWARE recommends the use of the password.lua module. As you can see here on the right, I have a picture again of a translator instance, and what's highlighted there in the red box is the password.lua script, and on the right are some various fields that correspond to its usage. I'll get into those a bit more later on in the walkthrough. So again, this module was designed by INTERFACEWARE, which actually utilizes the best crypto functions that we have available currently on 6.1 and above. And this module essentially stops credentials going directly into Git by utilizing an external configuration store. It's actually an XML file. But the additional step in this case with the password.lua module that makes it better than a typical external store is that the credentials are actually encrypted at rest. So this means that if the credential file were accessed directly and actually taken somehow, the credentials would be in a form that's unreadable. Credential data is only ever decrypted at runtime, meaning that they're only used in a way that does not persist their data when it's not in use. So to clarify again, in the context of password.lua, when a channel that utilizes this module starts up and run, at runtime, Iguana then decrypts the message inside the translator. And if it's initialized before the main, it will stay there in a form that Iguana can use actively to then access whatever connected or external devices that it needs to provide authentication to. Okay, so now that we've actually gotten to the end of the theory, and we've gotten to the end of the theory of what interfaces are and how they can be designed, as well as how can we encrypt the credentials that we use. And with all these points in mind, we're actually going to take a walkthrough of a sample interface that utilizes some of the concepts that we've actually discussed today. Today, we're going to walk through an interface of a known type. You can see here on the right that there are a couple of things here. There's an interface, there's some messages, there's a database. And what I want to say beforehand is that we know a couple of things. What we do know is that it utilizes HL7 messages. It has a SQLite database, and it has both upstream and downstream endpoints. Our goal today is to try and identify the type of interface and the design patterns it may utilize. And we're also going to identify which of the 3 configuration stores discussed today that it might use. And then lastly, we're going to ensure that any important credential data is encrypted. So this one time, I'm going to stop my screen share temporarily, just so that I can switch over to my Iguana instance. All right, so what we have here is an Iguana instance that was prepared today to walk through some of the concepts that we've discussed that are currently unknown at this point, but will become obvious fairly soon. And there are a couple of things here that we can see. So again, this is the Iguana, and this is the Iguana dashboard, which is gives you a high-level view of all the channels that you may have in a particular Iguana instance. And for the webinar, at least that we're discussing today, I have a couple of channels prepared to simulate an interface. Although there are a lot of channels, some of these channels do certain things that wouldn't necessarily exist in a particular interface. So as you can see here, I actually have a couple of channels that are listed from 1 through 5. And we have an upstream, which actually represents our upstream application, which would actually be external to our environment, which is represented by an E. Then we have the next 4 channels, which are all actually part of our interface that we're going to go through today. And we have 2 outbound receivers, which simulate outbound endpoints. So the first thing that we're actually going to try to do in this case with our interface is we're going to try and see what type of design pattern it uses. There are a lot of channels here, and I'm going to narrow it down to the ones that we have that are internal that we're going to focus on today. And we want to get a quick gauge on, what patterns we can identify. So the first thing that we can do to sort of see the routing of these channels, which would help us to determine if it's using any one-to-many or many-to-one, is by going to the left pane here. It's very subtle, but if you see on your Iguana instance, there's actually 3 dots located on the left side. And from here, there are a couple of things. There's some columns that you can use to then help sort your Iguana instances with a bit more granularity. And the one that we're going to focus on today is actually channel info. When we click on that, you can see here at the bottom in the global dashboard, there's a new column here that says channel info. And we're going to click on this button here that says routes. So once we click on that, we can actually see fairly quickly when we read through these where the channel starts and where the destination is. So at the top, we can see that our external upstream, it's going to itself, and that's because it's sending data via an LLP to simulate data going into our system. And channel 2 is that LLP listener that takes in that message and listens to it, and it sends it to our filter, which is number 3. After a filter, we can see here that, okay, it's actually going to 2 downstream channels, and then they go outbound to our external endpoints, our outbound receivers. So this in mind, we can quickly and clearly see that this interface is utilizing a complex design of one-to-many. So again, just to recap quickly what I did here to see that, I went over to the left pane here, and then under server columns, I clicked channel info, and I went to routes. Channel info is also good for some other things too. If you click on it, you can, it's an easier way for you to sort of globally select if you want channels to start automatically and to change the logging level and other things related to that. A lot of these fields might be useful depending on how you like to administer Iguana. So let's try and focus on potentially what configuration this channel uses and actually what's happening inside of this filter to begin with. So I highlight the filter translate component piece here. We'll click on edit script, and we can see a couple of things going on here. Inside our main, we have 3 comments that sort of describe in a nutshell what's happening. And first is it takes the incoming message and then it parses it. And then over here, we can see that it's using an example demo.vmd, and it's being used twice. Odds are if this is being used more than that, it would be best to put that into a configuration script, which we can see actually does exist, but we'll get to that in a second. After parsing the incoming message, there's a conditional check that checks if it's a right trigger type. And in this case, we can see on our annotation window here on the right, after parsing it, it does match the name or the condition we're looking for. And then it applies a code map over here. And then lastly, it serializes the message, meaning it puts it back into its plain text form and it sends it off to where it needs to go. So I'm going to take a quick look inside of the code map here. This function would exist inside of the script here on the left. And I can see that this code map is mapping the inbound message to the outbound message. And then it's doing a lookup for gender. So it's doing a simple lookup, which is, at least from what we can see here, changing, one letter gender names at least to the full male or female or other or whatever it needs to be. If we click directly into return lookup, we can see here that it's actually connecting to a database. And if we go back to our main.lua, we can see here that we actually have a database connection, which is specified outside of our main block here, which is good. That means that it can at least persist between connections, which would help speed up the queries as opposed to initializing a connection every time our main is run, which could then increase overhead. Inside of its API call, we can see that there are a couple things here that all say config.isLive, config.user password, config.dbuser. And before I step into the config.lua, which is actually where these variables reside, for those who are a bit more technically inclined out there, I just want to point out that unlike other databases like SQL Server or Oracle or something like that, if you are specifying passwords inside of here, if you're using SQLite particularly, you don't normally need a username and password combination. The use case here is just solely to point out for demonstration purposes where these passwords could be then stored and then either encrypted or not. So let's jump into the config.lua. And now we can see a couple things. We can see this config table, which has 3 tables inside of it that are nested, and they each have variables relating to a particular environment, such as development, test, and production. And some of those values are different depending on where we're at. And there is a return statement at the bottom that is utilizing os.getEnv. So if you recall during our presentation, os.getEnv is typically used to to get variables that are coming from the Iguana environment variables. So I'm going to jump over into that real quick and see what that variable is. So we're looking for server type. If we hop over here and look for that, we can see that server type's value is development. So if we go back over here, we can see that this return value is going to return the values that are under development here for the interface. From this point, we can already see two things. It's using environment variables and it's using a configuration script, which is really good for handling deployment. Because all of the variables are specified at once in one location, that means that in combination with this environment variable, if you were to push this code to another environment, such as your test or your production, based off of that variable, which is local to that one instance, it will load in a different one if it's test or prod, and then it'll pull in the other bank of variables here that can then be used throughout your code. As you can see here, this config is actually where I require that, and that's how it can then be used throughout the rest of the project. The last thing I want to zone in on here is that our password of our username and password is actually utilizing config.load, which if we actually look up here at the top, local config, it's using our encrypt.password.lua function, which means that it's storing our password in an XML file that's encrypted. The way the code is set up here, there's actually 3 lines that you can use to then modify the password, changing it, and instructions on how to do so, as well as a key that you can change here that is used to then hash the password with the rest of the commands that would then be available if we check here under shared password that it uses to then process the message. If you want to see more of this, I'm not going to take too much time to spend in here. Feel free to look at that on our documentation, and I'll show you shortly where that exists. So with that in mind, we can see that it does encrypt the variables that need to be encrypted. We're using a configuration script and we're using environment variables, which is all part of the best practices that we talked about. Before we wrap up this part of the walkthrough, I want to jump into these downstream channels here just to check something with its filter. So we can see that both these downstream channels, which are sending data outbound, they have filters in them. And if you recall what I had talked about in our discussion about one-to-many workflows, there it is. We have a conditional filter that checks for a particular field in the message. So it looks like it's checking for the sending application. And if it matches, it then pushes the message. And if it doesn't, then the message is filtered. It looks like if we go to our second one here, the second channel does the exact same thing, but with a different filter. So to conclude, that means that our interface is actually doing some dynamic routing, which is really useful when you need to send data to particular outbound connections based off of particular criteria. Okay, so with that all being said, I'm going to take this time to jump back over to our PowerPoint presentation. And again, this information or this workflow will be provided to you guys, after the webinar.
Yeah. Thank you, Marcus. That was fantastic. And once again, if you guys have any additional questions whatsoever, you're more than welcome to write to marketing@interfaceware.com. Everyone here will be getting a follow-up email with all the assignments that Marcus talked about. And once again, a YouTube link if you want to rewatch this presentation or want to share it with a colleague as well. We do have several questions, and so I'll go through a few of them as well, if that's okay, Marcus, or is there a few slides
Yeah.
complete
So
with?
no, I'm completely fine with that. Just if you would let me finish just 3 more slides, we can hop right on those questions right away.
Yep, absolutely.
Yeah. Okay. So now that we've gone over that, our success criteria, just again to summarize what we've learned, we're able to deduce that the interface was a complex interface that actually utilized some message enrichment via that code lookup and the change, and it had dynamic one-to-many routing. And in addition, the variables that were important, such as the passwords, were stored using a configuration script that got some of those variables from the environment variables, and it utilized the password.lua module that we had mentioned, which helps encrypt data at rest. And this actually does mark the end of the formal presentation webinar. And before we go into Q&A, I actually just want to answer two anticipated questions that I believe might have been simmering for a bit. The first is where you can get this module. The latest one you can get is actually directly from your Iguana instance in a built-in repository. It's called encrypt password and file from the built-in files repository. It hasn't been changed too much in a few years, and you can access it at that location. And again, these slides will be shared, so you can opt to get them now from a screenshot, or if you want, you can get them later. And then the second anticipated question is, do external variables persist between pull time? And again, the answer is yes, if they're referenced before the main function block. We have more information on that you can get from here. Okay, so that without being said, let's go into the open Q&A.
For sure. Thanks, Marcus, once again. So we have another question here about ODBC connections. And the questioner is asking, we use an ODBC connection from within Iguana to query an external database to look up data. We run a number of queries. Are there any options in Iguana to optimize this?
Okay, so if I'm understanding correctly, you have an external database that you use for some code lookups, and you want to figure out a way to optimize that. I don't remember the name of it off the top of my head, but we do have in our built-in repositories, I believe it might be under protocols or maybe the same protocol or location for the encrypt.lua. We have a database query caching. So what this means is if you know that you're doing particular calls to your database more often than not, if you utilize the code that's in that integration, you can then speed up the interactions because of the way that the code is able to then store some of those responses for you. If you know that you're using ODBC connection, this might be a good use for you in that scenario. Again, database query caching. You can also search that on our documentation to find a bit more detail.
Great. Another question is, can you use Chameleon to define an X12 VMD?
Yeah, the short answer is yes. If you have Chameleon right now, underneath the settings, I believe if you go to the top under options, there's a section there that lets you go to the VMD settings and you can specify what schema you're working with. It doesn't necessarily have to be H07. It can be X12. It can be anything that you want, really. We do have examples on our help.interfaceware.com that you can find fairly quickly if you type X12 VMD that you can start with and see how it works and tinker around with that.
Another question is, would it be possible to combine some of these design patterns? For example, using the message enrichment design pattern alongside the many-to-one design pattern, wherein the inbound channels are transforming the incoming information before sending it out to the same destination channel.
So yes, the way that you can do that again is by using multiple channels in sequence. So if you know that you have a many-to-one structure that has multiple upstream endpoints, in each of the channels that are connected that take in that data, whether it's from an LLP component to queue, if you add another channel into your chain, you can have a filter component in there with a translator that can then do a particular message enrichment, whether that's a code lookup or whether that's removing stuff from the message, so like a partial filter, and then after that adding an additional channel that would then route that particular stream into where it's being culminated. Again, depending on the complexity, introducing more channels would make your interface more modular and allow you to reach that level of granularity needed to add message enrichment.
Great. Another question is, could you define a variable in the config file that is value extracted from the HL7 that can be used within Lua files to, for example, pass into a database query?
Okay, so um, could you read that question back to me, Prashant? Just
Of course.
make sure I
Could
get
you
that correctly.
could you define a variable in the config file that is a value extracted from the HL7 that can be used within Lua files to, for example, pass into a database query?
Hmm. So I guess I'm not understanding the question fully correctly on this front. Would you be able to clarify that question a bit for me? Um,
So I can ask the questioner to provide
yeah,
more clarity,
yes,
and
the questionnaire.
we are coming close to the top of the hour, so I just want to be respectful for everyone's time. So I do have the questioner here noted down, and we could definitely send an email to follow up
Okay,
in
yeah,
regards to that, and we can get more clarity on that. We do have another question here, another one about
sure.
ODBC connections, and maybe this will be the last one for the day.
Okay.
We currently have hundreds of ODBC connections. What way do you suggest moving these connections when moving to a cloud-based environment?
Okay, so that is a that's a pretty loaded question because it depends on a couple of things, whether which cloud environment that you're going to, whether it's AWS or Azure or whatever else you might use, and how you plan to then interact with those how you plan to interact with those databases going forward. So um, if the question is how would you migrate from your on-premise to your from on-premise to your native cloud infrastructure, be first to see clearly what you have at your disposal, and then to work with what you have available at your options from there, and then take it piece by piece. And then that's when we come in, where you can talk to us, we can consult and work out the best workflow to sort of change each of those individually. I don't have any particular answers off the top of my head for any of the cloud services right now, but I do know that most of them, again, are done via an API, and that would be something where you might have to write a new interface or something to then interact with, and then handle the connection from there. Yeah.
So thank you, Marcus. I really appreciate that. That was a great presentation. To those who've asked questions and we weren't able to get to you, I do have it noted down here. So we will have that included, either personally messaging you with an email with an answer to your question, or even added to our follow-up email. So please do keep in mind, we are going to be sending out a follow-up email early next week. So keep an eye out for that. It will once again have a recap of this presentation, all of Marcus's slides, all his assignments, a survey that we'd love for everyone just to take a quick moment to fill out. And if you have any additional questions, please reach out to marketing@interfaceware.com. We look forward to hosting our next webinar in April. And if we don't speak before then, I wish you the best of health, and look forward to seeing everyone at our next webinar. All the best.
Thanks, everyone.
Thank you.